Good afternoon, or perhaps even good evening, everyone. And thanks for being positive. Oh, I'm supposed to start. Sorry about that. Good evening, everyone, and thanks for being positive and zealous enough to be here rather than being out grabbing a beer or something equally uplifting. Welcome to BOF 6357, which is a walkthrough of efficient code and project organization. My name is Lennart Jörelid. I am an architect and developer of J2E systems, basically. I've worked with Java and open source since, well, roughly 95. And we'll do this talk in 4 sections. It becomes a bit of a challenge since the code and the integration will mostly be in the last part. So all that goody stuff will be only at the end. But we start by investigating a bit of a problem which I've seen through numerous projects, which is the costly onboarding process, which is an instance of, an example of the effects of not using an efficient code and project organization. And then we'll go through the tiny bit of usability you actually need to know to be able to address that problem, and land in the tooling land and getting ready to organize your code and your project land at the very end of the talk. And following probably the end of the talk, we can have a Q&A probably outside of this facility. Right. Let's start with the famous disclaimer here. This is not to talk about Java programming in depth. There are like a gazillion talks outside of this one that would probably convey everything you ever wanted to need to know, and then some, about Java. I rather assume that you know how to program Java, that you've been a member of multiple projects, or at least a few of them, and that you know Maven, at least to a degree. And for the rest of you who don't know Maven, no worries. It will become a bit technical in the end, but I think you'll survive. It's not an in-depth usability engineering walkthrough either. Instead, this is a talk aimed at inspiring you, empowering you when you get home from this session to try to change and make your workplace a little better. Basically, to consider yourselves as developers and possibly the developers that work with you as users, to which you have to design stuff. Not only users of your system, but yourselves as well. You're very important users of the system, and that part of usability engineering tends to evaporate with some not so desirable consequences. All right, let's start with the problem at hand. And since it's rather late in the afternoon or even early in the evening, let's start with a bit of gymnastics. So hands up those of you who works or have worked in big projects. Okay, all of you. And hands up those of you who moved between projects a lot. Quite all of you. And okay, so hands up all those of you who felt that the introduction you got to, say, your latest project was really great and you got the whole thing just by being at the introduction. No. None. Okay. And then the experience, did you feel that there was tooling in your projects that helped you reduce your need to sit and read through lots of documents or query lots of collaborators for the mentoring stuff? Was there really good tooling in your project? Wow. That was actually more than I would have expected. It was like 10. All right. We move on to the second part of the defining the audience. Hello, dear audience. Who of you studied usability engineering? Hands up. Well, a few of you. Who of you designed APIs, first of all? And designed APIs using the principles of usability engineering? A few. Okay. And yeah, that would probably be a bit difficult then. Who of you used usability engineering to design your own build or version control system? That would probably have been rather few of you, considering few of you actually studied it. And to take it one step further, who of you set up maven plugins to define the build of your entire reactor, to give feedback to developers when the guidelines that you set up as architects or developers were actually broken? Basically, when they introduced dependencies into projects, but they were not really supposed to introduce them there, or wrote code that didn't quite comply with your check styles. Like a handful of you. Okay. You see a bit disconnect here? How many of you worked in big projects? Okay, enough said. So the problem statement is that generally introduction, and I've seen this over and over again, introduction of new collaborators into a project is really costly, and it's rather difficult to find and understand and then apply the standards which were given in the introduction, which you yourselves just claimed really didn't help you at all, right? And so the phenomenon is sort of, where are the standards? And when I'm sitting developing, how do I know where the standards are? Do they exist? Should I search for them in some Teamplace or Wiki? Should I download them? And by the way, does it apply to the situation I'm currently in? Wait a minute, I think I'll stop coding for 15 hours to actually download the documents, read it, understand it, and then apply it. No, that situation doesn't quite ever occur. So the version control systems generally tend to be structured for creating a build, for defining a reactor, not to assist you or anyone else understanding. So generally, the introduction looks something like this. If we go to the meta level and introduce the life cycle of a coworker within the project. Welcome to this glorious new project, dear coworker. I am the manager. Oh, sorry, I am the manager. So I have no humor. I will now give you a presentation of our organization. You will get 3 hours worth of slides detailing who everyone that manages parts and divisions of our organization is. Now, thank you so much. Fast forward 3 hours. You are not too much the wiser, but I guarantee it was lots of information that you didn't quite absorb. So we send you off to the architect or even the business architect, and he or she gives you a grand product presentation. We have 10 products. You're working in Scrum Team X with product Y for division Z, and by the way, they relate in this way to every system in the whole world. And after that presentation, you have a slight tendency of being a bit dizzy, not really understanding more, but being more dizzy. So you're sent away to the Scrum Master, the Scrum team, or project manager, depending on how you're organized, and you get the backlog, the sprints, the stories, and yet another sense of the reality you're supposed to work in, which doesn't really connect to what you were just presented, right? None of these things actually connect at all. It's just that, and they don't connect at all to what you're supposed to be doing, right? Perhaps we're getting there, but not quite. From the looks of your faces, this is really hilarious. I can tell some of you have actually been through this. And then starts the very frustrating phase, the learning curve. You have to download stuff from the wiki. You have to read stuff. You have to understand it. And you have to pester your coworkers with questions from everything like beginner stuff to very complex stuff, to arrive at the productivity phase where you actually can start doing something that you know how to do, take informed decisions, and so on. Now, this is the general life cycle if you come into a professional project. How many of you work with open source projects? Hand up. Grand. Then you get roughly that. You don't get any presentation whatsoever. You get the wiki or the documentation and nothing else. And sometimes we at Apache wonder why people have such a high threshold to actually get in and start committing stuff. Right, so this is the problem. The learning curve is steep, it's costly. Wikis and Teamplaces consist mainly of documents. Documents tend to be problematic in that they consume enormous amounts of time to produce, They're actually difficult to understand when you read them, not to mention that you never know if they're actually stale or updated. Who would you ask? Whoever wrote it left the company 3 years ago. Yeah. And they're time-consuming to read. Did you actually understand it? Who are you supposed to ask? Your coworkers, and they will be happy to answer you, I'm sure. So we need to somehow to get a sustainable development pace here. And while, by the way, those of you guys who take pictures of this, grand that you do, if you want to, just send me an email and I'll send you a PDF of this. It probably doesn't make too much sense, but you would probably save some megabytes on your cameras. So we must find some way to reduce the need to read the documentation, because that increases the development pace and the project pace. And we need to reduce the number of concepts in a version control system. Generally, if, let's see, how many of you build stuff with Ant and you have rather few projects which have huge amounts of packages and classes in each build? Hand up. Oh my goodness. How many of you build stuff with Maven where you have slightly smaller code bases in each project but 256 projects in the reactor? Lovely. From those of you who just, the Maven part of you, how many of you actually understood and saw patterns in all of these projects from day one? 2. That says a bit, doesn't it? So it's important to reduce the number of concepts in a version control system so it can be chewed, so that it can be portioned out to us all in mouthfuls that would make sense, that we could understand and actually process. And those would have to comply with a development specification, by the way. So having understood a bit of the problem, and it seems almost silly to walk through it because all of you seems to sit there and nod, smile slightly and understand this problem. We've seen it 200 times before, yeah. But how do we rectify this situation? There are a few fairly simple approaches to do this and some very complex. We'll start with the simple, or simplistic ones, I should say. We need to apply usability engineering and the principles of human-computer interaction to the way we design projects, to the way that we structure the projects, both in terms of builds and code and also organization. I won't deal with the organization at all. I'm sure you have managers who have nothing better to do than dealing with the organization all day long. But I will deal with the code, because that is such a powerful means, the version control system, to convey meaning and to convey semantics. So we have to originate from the human mind and how we learn stuff, and then adhere to the standard design principles. And this requires some basic knowledge of how we learn stuff and the design principles and some of usability engineering. Now, I won't go into much detail about this, so no worries. But the 101 on memory and learning is something like this. The eyes and ears, or whatever, the senses, receive sensory input, which sort of stays in those senses for just an instant. It vanishes almost immediately. Thankfully, it vanishes to the brain from the sensory organs when it goes into the short-term memory. And the short-term memory, or active memory, depending on which school of psychology you actually work with, is a rather interesting piece of the brain, which stores 7 plus minus 2, is the commonly accepted definition, things. Now, things is something that is rather abstract. A thing can be everything from objects on a table, there are like 7 things here, to 2 rows, or to groups of people, to things. So things, in terms of programmers and version control systems repos, can mean structures of projects rather than just one project or one class. All right, so the short-term memory is, as it were, short. So information in there stays for a few seconds, but not more. And then, hopefully, it sort of moves slowly, or hopefully quickly, into the long-term memory, where basically an unlimited, or sort of unlimited, amount of information can stay indefinitely. Now, that's the principles of learning. So we have to remember this with 7 plus minus 2 for the short-time memory. Whereas design principles, the standard ones of human-computer interaction, these are but a fraction of it. But they are very obvious when you think of them, and for some reason, very unobvious to apply to everyday life for us as programmers. Well, let's start with 2. Visibility. What does an object do? If that function is apparent, then the object has a good visibility. So a hammer would work really visible. It's got a handle which sort of invites you to grip it, and then, and then you bang on something, not someone. And you could just consider the rather poor example of a design to the right there. It's a door handle, right? And normally you have got big flat door handles which you're supposed to they invite you to push. And when the design and the intuitive way of using the stuff doesn't really, coincide, but rather go opposite directions, then you get this door handle, and you have to have a sign telling you what to do, because obviously people would go, push. So not completely stupid people, but a rather interesting design, shall we say. So that's visibility and affordance. What does the object do, and how do I use it? Consistency. Repeating yourself is a good thing in terms of design. I use one car just like I used another car. Even if you haven't driven a nice new Lexus like ever, and a car is a very complex piece of machinery, I bet you, if you have a driver's license, you could just as easily sit down in that new car you've never been in before and keep on driving because of consistency. The steering wheel is in the same place, the gear shift is, well, if you have one here in the United States, but it's in the same place, and the pedals do the same thing. Consistency. The same thing can be applied to software engineering. If we have a large number of consistent groups of stuff in a version control system, then we immediately apply the same thinking over and over again. And basically, if we just solve one of those little pieces of the puzzle, then we can work with all of it without having to relearn everything. So consistency is important. Constraints. I can only use an object in a certain way. If you've got unleaded fuel, no, wait a minute. If you've got leaded fuel, you can't put the nozzle of the thing in the car because they won't fit. So that's a constraint. Menus are typical constraints in software engineering. And the build process in terms of version control system is a constraint, or can be a constraint. It's very important to get feedback. A build system which doesn't give you feedback, even if you do something wrong, conceptually wrong, or break some of the rules of the development guidelines, is basically incomplete. Because you as the developer shouldn't have to read stuff or to question someone to know that you did something which didn't comply with the rules. You're supposed to get immediate feedback. So something has to give you that feedback and check. Feedback is important. So now you're human-computer interaction experts, and you know everything there is about design principles. Right, let's start applying this. So if we combine usability engineering with repo structures and project structures that we normally work with, we wind frequently up, or so is my experience, in components. Division of entire repos into components. The problem with components, which we sort of try to have in groups of 7 plus minus 2, right, is that the term component is probably one of the most overloaded terms you could ever find. So, bad. Let's see what I mean with component. Now it's starting to getting interesting. Software components are essentially a solidification of patterns. So a sustainable way to reduce dependency entanglements. It's really important to ensure that you can sustainably and in a controlled manner ensure that you do not wind up into a complete big ball of yarn, that legacy system where you want to refactor something, but if you touch that little bit, you have to touch everything in the entire system because it depends on, or rather it has dependencies upon everything, which is a bit of a problem. Then the refactoring speed is, of course, reduced considerably. So we have to devise some kind of interaction pattern and dependency pattern to reduce that possibility. We have to have dependency control to enforce that dependency control. You're supposed to only depend upon API projects and not depend upon implementations ever. Okay? How do we enforce that? And it's important to simplify. If you have this huge ant repo where everything is different, it's just packages and classes everywhere. They probably have some structure. They particularly had some structures 10 years ago when the repo was started, right? But now the structure has sort of mutated over the years, developed a life of its own, getting the privilege to vote, and it's very complex to see which bits actually go where. So we have to use software components or some such structure to simplify it. Okay, into the gist of it. Say we've developed a component named X. Substitute with caching, parsing, XML binding, your vehicle something component, a component. It is a project, a Maven project, and it has a few projects below it, and I mean below it as in a file explorer, but within the version control system, right? So X would be a directory, and it would have this slush of projects below it. A model, an API, an implementation of some sort, an integration test, and possibly others. If we haven't got a model, so there are no entities for this particular component, I'll refer to it as a library. It's basically something like caching. There's no caching model. Like you take anything really to cache, so it has no model, it's a library. But if you have a model, then it becomes a domain component, because then you try to model the pieces of the domain within entities in the model project, right? So a component in this case, cache, for instance, would hide itself below a directory called cache, and then would have a slush of projects, each of which would do it or play its particular part to create or to build up this software component. And you can also do things that is very rarely seen, but I really find these really useful. How do I use a cache? Then frequently I've set up cache example projects or parser example projects or whatever example projects, which basically contains copy and paste code. If you don't know what a cache does and you have to work with it quickly, you open the example project. There are 3 classes there showing the typical usage of the cache, so you copy the code and paste it. If you really want to know how the cache works, go into the API and take a look. Forget about the implementation. You never know which implementation is going to be injected anyway. So all of the complexities in the implementation you just now completely reduced the need for. So this is an example from a project here which contains relatively few, sort of almost 7 plus minus 2, but we're pretty bad at calculus, so it's actually 10 projects here. But components, so it's much easier to see this 10-ish, 7-ish number of projects which actually implement components with the same structure just described below them, than seeing all of those component projects, because then it becomes a huge list of something you have to make sense of, and it becomes too much for the short-term memory, so you don't grok that 7 plus minus 2, and it takes time, whereas this is much quicker. I'm interested in the cache. Okay, open the cache. I've got 4 projects there. Grand. So if I open up one of those components, the cache in this case, you got the API. There's no domain model for cache. You got the cache example, and you got 2 implementations. One obviously implemented with cache, and the other one with Hazelcast. Grand. Now I know even the implementation types. I don't know the exact parts of it. I just need to interact with the API. And by the way, I can see how I do that by going into and copy and pasting code from the example projects. Wow. How much time did I have to spend on learning the cache now? Zilch. Because this thing is kind of easy to digest for all of us. We're programmers. This is easy to comprehend. And those examples doesn't really, well, they don't get all that complex. And so we've just cut the learning curve drastically here if you're new to using a cache. I know, kind of silly example, but you get the picture. So the component projects and 2 different implementations, yeah. It's also very important to reduce dependency tanglements. This is one of the things that really can muck up a product. So you've got the model product, that's the model project. It contains component entities and domain entities, which is basically annotated POJOs, throw in JAXB annotations and JPA annotations, and the entities can then transform themselves into XML and SQL, depending on what you need. And then you have to depend on that. So the API needs, of course, to accept domain entities as arguments to its functions and probably emit domain objects from their functions. So the API has to depend on the model, but the model cannot depend on the API. And you got an implementation which can depend only on the API and not the reverse way. And then you got the integration tests, which can depend on the implementation to actually do integration testing, the likes of fitness or whatever you use. So you got this this rather easy to understand hierarchy of projects which works in concert, in collaboration to achieve something. In this case, an X, but a cache or something. So this is one of the strategies. There are several others, of course, but to apply usability engineering to your own, to your own projects and to your own everyday work. And all of a sudden, you'd probably see a huge boost in productivity, particularly if you have to enter some area of the project where you haven't been working before. Now, expand that to a project of 400 developers and you realize where I am. This is very, very cost saving. And it's also very efficient. So we'll use these principles to actually achieve a project structure which conveys semantic meaning to you and which facilitates or simplifies our everyday work. All right, this doesn't happen by itself, and it certainly doesn't happen because we have a few architects who wrote a development guidebook and threw that on the Wiki. So we need to have something to enforce, we need to have something to enforce these guidelines. And so enter tooling. And now we get to the codey bit of this session in a while. So tooling is supposed to reduce the need for documentation, enforce if possible, and document if you really have to. That's like write once, run everywhere, but no, it isn't really. But that's the spirit you can repeat. Try to enforce it. If you really can't enforce it, and if you have to document it for one reason or another, then document it. So you can configure all this tooling in one shared Codestyle project. And this one is supposed to be global. So you need a particular reactor to define the build, where one of the projects is a Codestyle project, where you define things like configure check style, where you define a lot of plugins. I'll come into them shortly. But this is a global dependency and will be everywhere, used everywhere in every reactor. And the point of it is, of course, that enforces a consistent development style throughout the organization. And this is a version-controlled definition, which is also a tool usable with every build to enforce that development guideline, not just say it's a development guideline and throw the document in Teamplace. There are several Maven plugins that exist to facilitate this. We'll take a look at 3 of them. There are a gazillion, so I'll just take a look at 3 of the most important ones. The Maven Enforcer plugin, which basically defines, it inspects a Maven POM and whatever is done with a Maven POM, dependencies, plugins and whatnot, and also external aspects such as JVM version, Maven version, operative system version, or what have you. And you can run checks on it to ensure that you're supposed to run the same JDK, you're supposed to run the same Maven version, you're supposed to run whatever. And as we'll see, this is probably the place where you'll be writing a lot of custom plugin definitions to enforce your development guideline, to make sure that you don't have the possibility to include an incorrect dependency, which would later on jettison or, well, threaten the project. The Checkstyle plugin goes to the other level. Whereas the Enforcer plugin took a look at the POM, the Checkstyle plugin goes into the code and makes sure you can check various aspects of the code. And the Cobertura plugin, in its turn, checks for test coverage so that you have enough sufficient unit test coverage of your code. All right, before I start getting technical with all these, let's see. How many of you have used and configured the Enforcer plugin? Hands up. Okay, a few of you. Good. How many of you have configured and used the Checkstyle plugin? Bit more. And how many of you have used or configured the Cobertura plugin? Roughly the same. All right. Then I won't skip any one of them because there seems to be lots of it. But I'll go through them in that direction, on that order. Enforcer, Checkstyle, and Cobertura. And remember, this is an example. There are like a ton more of stuff to check. So it's really easy to add most of these plugins to the build. The problem is that the configuration of all of these plugins are different from every one of them. So the guy or you who defined the build cycle and actually the build process and define how the plugins should interact with the code and the project structure need to know exactly what all these options stand for. So you need to read the spec. Sorry, no getting away from it. The good thing is only one person has to do it once, and then it will be applied to everyone. So it's just a snippet of the POM where you define the plugin goal. So in case of the Enforcer plugin, the relevant goal is enforce. That would actually start its rule checks and do the interaction with the code and the build. And there are quite a few stock rules which come with the, standard rules that come with the Enforcer plugin. Like in this case, we need to use version 3.02 or upwards of Maven and a certain variable defined JDK. But the important thing here, and this is probably something that someone needs to do, is to create a set of custom rules. These would be ones defining, or rather enforcing, the development guidelines. You're not supposed to import implementation dependencies into. You're not supposed to have dependencies introduced in reactor POMs, only in parent POMs, and so on. So for each of those, you need to enter a custom rule, and I'll show you shortly how that's done. It's not difficult. And then, since your custom rules, they are classes, so have to be implemented somewhere, and you have to, therefore, introduce a dependency to the project, the Codestyle project, where you actually define them all. There are quite a few existing stock rules, and these are just a few of them. There are quite a lot of them. But generally, the stock rules set some kind of exterior boundary. They don't really do anything with your particular development guideline, so you have to do that yourselves, generally. And the process to do this is you create the Codestyle project that holds all your rules, and you import the Maven APIs that you require to create these Enforcer rules into the Checkstyle project, the Codestyle project, sorry. And then you implement, so one class holds a particular rule type. We'll show that shortly. And you use, just like we showed, this enforcement plugin to apply your rules in your POMs. Now, we took a look at how to insert the POM just earlier. And we know that we have to create a project. So remains the imports and what you need to implement. This is the import stuff. And you really, verbatim, can copy this. You need the Enforcer API itself, which is the topmost dependency there. And then you need the Maven dependency so you can do stuff. The Enforcer plugin is supposed to dig out stuff from Maven and then use that to check if you have dependencies or whatever. And those classes are found in the Maven integration APIs. So what is an Enforcer API? What's an Enforcer rule? Well, this is the interface that defines EnforcerRule. And apart from the three rather unimportant methods below, this looks roughly like a servlet. The execute method, corresponding roughly to a servlet's service method, is where Maven actually invokes to check the rule. And the contract is, all right, it's a void method, so you don't have to return anything. You get this EnforcerHelper thingy from Maven, which is the entry point to Maven. And then if everything goes well, don't do anything. If you find something that is remiss, throw an enforcer rule exception. Right? This EnforcerRuleHelper thingy is something you can use to dig out stuff from Maven. And for those of you who read a POM, you know that these expressions actually define variables within Maven. So you can actually extract the underlying Maven objects. It's sort of like a glorified hash table, right? Nothing really strange about it, but you can do a get. Unfortunately, you also have to cast the objects. But never mind. That will probably come naturally. So you get stuff like the artifact ID or the project and do things with it. And then you implement your custom rule. And in this case, it's a really, really tiny one. At last, we've come to a portion of the development guideline saying project type get project. What's that? Well, this is something that I put up as an example because it's very, very useful and something I recommend you to do. This little thing is something that you definitely have to implement. It's an enum. Enums are really good in that they are very clear with what the available options are. In this case, it's an enum defining all the possible project types and exactly what constitutes a project in terms of a Maven POM. So if the Maven reactor encounters a particular POM which doesn't sort of comply with one of these definitions, then it will break the build. So you always have a well-defined project type. That's the idea. Now, what is that? Let's see. So it's something that's really simple. In this case, it just checks group ID as a regular expression, artifact ID as a regular expression, group ID as a regular expression, and packaging. And if I can't get any of these combinations to match, then it's not a well-defined project and we should break the build. Now this is just a trivial example, but you can see that clearly this is quite a powerful thing. And then you've got the interesting parse method down here saying get project type and really doing the whole parsing of the POM and returning eventually a project type. If I don't find one of these well-defined project types, kill the build. All right. So there are a gazillion of these nifty rules to enforce the development guidelines. Take a look at the Maven Enforcer plugin. It's really simple, but you have to learn a bit about the Maven APIs to know things like, I don't want to import certain dependencies. Okay, how do I find them from this EnforcerRuleHelper? And how do I determine if they're okay or not? But it's not much more than two methods away, and you have the answer. So take a look at it. Check style. More people had configured and played around with this, so it's not I'll be a bit briefer with it. Just as simple as the Enforcer plugin to add to the build reactor. In this case, the check style version, and it has a dependency upon, the Codestyle project again. So the configuration, for the check style plugin resides in, you can see it over there, Codestyle/checkstyle XML. That means you have the resources here, Codestyle, checkstyle. Grand. You've got one global checkstyle which will apply to every project which has code. And if the project doesn't comply with the Codestyle, then checkstyle will break the build. Nice. So And we just took a look at the Codestyle project. For instance, this is one thing that has been rather difficult to wipe out until we did a check-style rule for it. This rule says it's illegal to have a parameter return type or a method definition, return or argument to a method to be one of Gregorian calendar, Java util calendar, Java util date, or Java util vector, because we want people to use other classes or other alternatives. And this would break the build in case it was incorrectly configured. Nasty, yeah, but very efficient. So I'll basically skip the rest of check style. It's easy enough to do. There are hundreds of rules that you could tweak to really go into the code and make sure that people don't format it incorrectly and don't use incorrect arguments or types. And in this case, the last part of it is Cobertura, which basically, the only really relevant stuff that Cobertura does, it does two things. It helps you to see the coverage of unit tests. So how big a portion of your artifact code is covered by unit tests. All right, just as easy with Cobertura as with the other plugins. It's just to enter this in the parent POM and define that it's probably a bad idea to check Cobertura for stuff that isn't in your reactor. So you probably want to limit it a bit so that it checks only your code. And you probably want to exclude stuff that, things like generated code, not too much of an idea to check unit tests for generated code. It doesn't really convey anything or do anything. And then in the bottom, you've got the default rates, the branch rate, the line rate, which are the two important things, and the halt on failure, which basically says break the build if the coverage is insufficient. This is really important. Otherwise, it's just an advisory thingy. And we all know what happens with good pieces of advice after a few months, particularly when it's really close to delivery time. Yeah. So there are two pieces of information, two relevant ones. One is line coverage. How many % of the lines in the artifact code are covered by the unit tests? And the other one is how big a % of all execution branches through the code are covered by the unit tests. In a report from this plugin, you can see basically graphically rather decently illustrated the coverages. And when you build Maven site, you will get all these reports. So it's very easy for a developer to build these things locally, check it out locally before committing stuff. It's always nice to have feedback beforehand. So it's the index.html. This is a Cobertura report, where you can see the different coverages for different packages. And if we go into a sample report, it becomes really, really clear which pieces of the code are covered and which are not. So in top of each class, you've got this line and branch coverage numbers, right? And to the left side, you can see that there's if you've got eagle eye vision, particularly if you're in the back, you can see that that particular line was covered 16 times. It's a green number. It's okay, it's covered, and it's covered 16 times. Whereas down here, you got two red lines. One is covered 12 times, and the other one isn't covered at all. So this is one of those things where you tested one of the if conditions, but you didn't test the other ones. So then you always have to ask yourself, when you get something like this is a really good tool. Did I miss to write the correct tests? Or have I written unnecessary, really, crap code? Should I remove it, or should I increase my tests coverage? One or the other. And becomes very clear. So if you mouse over one of these reports, you'll see a bit of an explanation. The report is clever enough to tell you you've only got 50% coverage here. So that's automatic enforcement. And as I said, there are 200 other ways to do this. I'll conclude by saying that if you do this, if you have a build process in a reactor which actually contains enforcement tools to enforce your development guidelines, then both you yourselves and the rest of the crew will probably have a much easier workday. So I have thrown the code of this up on Bitbucket. If you want to clone it by Git or by Mercurial, then do so. If you want me to send this presentation in PDF form, just come forward after the presentation and give me your email address and I'll send it out. I would be really grateful if you could wait for like a day before cloning stuff here, because I found out that someone had introduced a bit of a bug. No, because it would be really grateful for you to do that, because it would work better. So there's a proof of concept. Clone it, send me some feedback, and we can improve it together. That's an Apache license, so you don't risk anything by doing anything. All right, that's it. And we're also spot on time, I see. So I guess Q&A would be in order, but probably outside of this room, right? All right, thank you so much.